For centuries, humanity has looked to the skies trying to decipher the silent language of the stars. Among the many celestial mysteries, one of the most haunting remains. Was there once a planet between Mars and Jupiter that no longer exists? And if so, did Jupiter destroy it? Let's examine the evidence with an open mind and a scientific lens. We already know that the asteroid belt sits precisely in the zone where this mysterious planet, Fyatin, would have orbited. Some scientists in the 19th century were so convinced of this planet's prior existence that they named it in theory, long before space probes or high-resolution imaging were available. But with time and technology, the theory evolved, or rather, diverged. Modern astronomy largely supports the accretion theory, the idea that the asteroid belt represents a planet that never formed, its material thwarted by the gravitational influence of nearby Jupiter. However, this doesn't fully explain the orbital paths, the mass distribution, and the chemical diversity of the asteroids within the belt. Some asteroids are carbon-rich, others silicate-heavy, and some contain metals like nickel and iron, in amounts usually found in planetary cores. How could such differentiation exist if no full-sized planetary body ever formed there? This is where the disruption theory re-emerges, with a vengeance. According to this idea, a planet did form in the early solar system and was later destroyed, either by an internal cataclysm or, more intriguingly, by Jupiter's massive gravitational forces. Jupiter is not just the largest planet in our solar system. It is a cosmic bully. Its gravitational reach is immense, capable of altering the orbits of moons, capturing comets, and flinging asteroids out of the belt entirely. In fact, some scientists call Jupiter the solar system's vacuum cleaner because of the way it clears debris. But what if Jupiter did more than just clean up? What if it tore apart a young planet that dared to form too close? The physics support this possibility. The region between Mars and Jupiter sits near the so-called Kirkwood gaps, areas in the asteroid belt where no asteroids are found. These gaps correspond to orbital resonances with Jupiter, meaning that any object orbiting there would receive regular gravitational nudges from the gas giant, nudges strong enough to destabilize its orbit over time. Imagine a young, newly formed planet, Fyatin, caught in these resonances. Each time it completes an orbit, Jupiter tugs on it slightly. Over millions of years, these tugs build up, like waves eroding a cliff. Eventually, Fyatin's orbit becomes so unstable that it either crashes into another object, is pulled toward the Sun, or is shattered completely. Such a scenario could explain the asteroid belt's fragmented composition, chunks of crust, mantle, and even core material drifting separately in space. It also aligns with impact evidence found in meteorites on Earth, some of which appear to have originated from large, differentiated bodies. Jupiter's role in shaping the solar system is complex. While it protected Earth by deflecting dangerous comets and asteroids, it may have also prevented another planet from forming or surviving. In this light, Jupiter is both a guardian and a destroyer. And what if this destruction wasn't a one-time event? New models suggest that the early solar system may have been far more violent than we once believed. Planets may have migrated, shifted positions, and even swapped orbits due to gravitational interactions. Jupiter itself may have moved inward before settling into its current orbit, bulldozing through planetesimals and disrupting any forming planets in its path. This chaotic reshuffling is known as the Grand Tack hypothesis, and it supports the idea that entire worlds could have been displaced or demolished by Jupiter's movement. But here's where things get even more fascinating. Some scientists believe that the asteroid belt might not be the only graveyard in our solar system. Closer to Earth, we find the main belt comets, icy bodies that orbit within the asteroid belt and occasionally release gas, much like comets from the outer solar system. These bodies blur the line between comets and asteroids, suggesting that the asteroid belt may have had icy, water-rich worlds, possibly with subsurface oceans, like those we suspect on Ceres. If true, then Fyatin might have been more than just rock and metal. It could have been a wet world, with oceans, clouds, even potential for life. And here's a question that keeps scientists up at night. If Fyatin had time to develop life, what happened to it when the planet was destroyed? Could microbial life have hitched a ride on fragments hurled into space? Could they have landed on Mars, or even Earth, carried via panspermia? The theory that life can travel across the universe on space rocks. While there's no hard proof yet, the idea is not far-fetched. Scientists have already proven that certain bacteria can survive the vacuum of space for years. If microbial life existed on Fyatin, it's not impossible that some of it could still be alive, sleeping in a rock waiting to be found. Think about that. Somewhere, drifting between Mars and Jupiter, could be a fossilized piece of an ancient living world. Maybe it's already landed on Earth. Maybe it's in a museum drawer labeled as just another meteorite. Or maybe it's waiting for us to find it. In the next segment, we'll explore how missions like OSIRIS-REx, Hayabusa 2, and Dawn are helping us unlock these mysteries by bringing back samples from asteroids, studying their composition, and possibly revealing the fingerprints of a lost planet. These missions are not just technological marvels, they are time machines, reaching into the past and pulling out secrets that have been frozen in rock for billions of years. So the question remains, did Jupiter destroy a planet in our solar system? Maybe it did. Maybe the evidence is floating in space right now. Or maybe, just maybe, it's already here, beneath our feet. Stay tuned to Infinity Beyond, where in our next episode, we'll unravel the secrets behind the spacecraft exploring asteroids, bringing home ancient relics of cosmic history, and perhaps answers to questions as old as time. And if you're enjoying this journey, don't forget to subscribe, like, and share. Let's explore the forgotten corners of our solar system together.